we're going to start by just reviewing the classic 30, 60, 90 triangles. So that kind of looks like this. I actually usually make my 30, 60, 90 like this, but there's no reason it has to be drawn in that orientation. You know, you could make it like that. You just got to make sure that your 30 is across from your shortest side. All right, so everybody label your 30, 60, 90 triangle. You should know those three numbers like the back of your hand. Boom, boom, boom. And then make another one. What I'd like to do to just kind of add some zip to this is make your 45, 45, 90 like that. Do you get how if it butts right up to the back of the shortest side, then these can both be 1? You know what I'm saying? Whether it's the blue one where it was 1, 2, and the square root of 3, and then on the black one it'd be 1, 1, and what's the third one? Square root of 2. All right, so these have to be just automatic for you. But why then do I have the 1 in different spots? Does anybody remember why I would move the 1 and say I want that side to be 1? Yes.
Because the unit circle.
Exactly. Everybody please go and make a circle inside, and inside of it put the X and Y axis. Because see now, if I was going to make a 30, 60, 90 triangle now, everybody draw this little red triangle inside that circle. Now if that's a 30, 60, 90 triangle, what's wrong with just saying that it's 1, 2, and the square root of 3? Nothing is wrong with that. Unless they tell you that the radius is 1. In which case, I'm going to do what to everything? Divide by what? 2. Do you get how our side that used to be 1 was the smallest side, now all of a sudden 1 is the radius? Now those aren't as nice. I don't have you memorize them like that because they're not as nice. But for the unit circle, it's pretty handy. Because then this spot here becomes x, which is root 3 over 2, comma y, which is 1/2. Please label that now, too. If this is a point that you had to get to, you would go over root 3 over 2 and up 1/2. That's why this is the x and this is the y, because you go over and then you go up that amount. And then what did I try to connect for you? That sine was what? Sine is y. Good. So then this part right here is the sine. So if this right here was a 30-degree angle, AKA, another thing you have to have memorized, pi over what? 30 degrees is pi over what? Pi over 6. So many things to know. Maybe you forgot them over your long weekend. So if that's pi over 6, same as 30, then what's the sine of pi over 6? Well, I personally would have just done this over this. Sine is opposite over hypotenuse. But wait, you could just call it the y value, which is 1/2. There's 2 ways to do it. With opposite over hypotenuse. And if you're doing it with opposite over hypotenuse, it's 1/2 over 1. We changed the numbers from originally it was 1 over 2. But either way, it's 1/2. Or I could do the sine is the y of it. But once you've got this spot, it's really easy to go, well, sine's the y of it, cosine's the x of it, and tangent is this divided by this. So 1/2 divided by root 3 over 2. Do you see why this fraction over fraction thing was part of my thing you had to know for the top 20? Fraction over fraction's happening a lot right now. And then all of a sudden you got to know that that means times and flip it. 2 over root 3, and then the 2's cancel, and apparently it was just 1 over root 3. That's a way to get tangent from just a point. All right, now I'd like to go back to this, and it shouldn't be that hard for you to go, oh yeah, I see this is the 30, 60, 90. And normally it would be 1, 2, and the square root of 3, and then this will make you go, okay, so what do I do to all of the sides? Oh yeah, I want to divide all the sides by 2. So now, those are the proper sides. 1/2, root 3 over 2. And this one used to be 1 and 1 and the square root of 2, and then you got to think to yourself, if I want that square root of 2 to actually be a 1, this is what I better do. So finish this off, and in a moment, I'm going to have you compare with the kid next to you. You're going to be comparing these side lengths for these two triangles here. I'll pause for a second, give you time to work. So we're just kind of easing you into this here. This needs to be a 1/2 right, or sorry, a 1 right here, so I got to divide that by root 2. Divide by root 2, divide by root 2, and then this is now 1, just like I wanted it to be. And then this is 1 over root 2. Did anybody take the time to rationalize it? Remember, you don't have to, but did anybody? I'm curious. Okay. That is smart because the unit circle is going to say root 2 over 2. And that's what this is. Root 2 over 2 and root 2 over 2. Okay. And it's the same as 1 over root 2. I would accept both answers. But when you see root 2 over 2, you got to know, oh, where'd that come from? Root 2 over 2. All right, and in this last one, I would go 1, 2, square root of 3, and think, how do I make a 2 into a 1 like I want it to be? Divide everything by 2. And I'm back to those sides. This short side's a 1/2. Longer side's root 3 over 2. All right, so then you should be able to just fill this in. I am not kidding. From memory? No. That would be completely optional. But you should be able to fill in this entire thing. Now I'm going to help get you started with this one right here. And let's put in the degrees on some of them so you kind of see the pattern here of what they want. All right, so what they want is that this right here is 0 degrees. This is 30 degrees. This is 45 degrees. This is 60 degrees. Okay. And then that little fraction bar there, that's for it in radians. What is 30 again? Pi over what? 6. What's 45? Pi over what? 4. Good. What's 60 degrees? Well, technically it's 2 pi over 6s. But that's the same as 1 pi over 3. Good. And then this one's 90 degrees, and it's pi over 2. You see how they want those filled out? Now, how do you keep going on those? Well, I like to do it this way. Once I have 1 pi over 6, I just keep going. That's 2 pi over 6. That's 3 pi over 6. That's 4 pi over 6. 4 pi over 6. And I won't mark it wrong if you say 4 pi over 6. Why? Because I think this is a great way to count it up. 1 pi over 6, 2 pi over 6, but I have pi over 3 there. It's just reduced. 4 pi over 6, yeah, it could be reduced, but that helps them get to 5 pi over 6. Do you get the kid that reduces that to 2 pi over 3? Then they can be stuck. And they're like, I don't know what the next one is. If you leave it as 4 pi over 6, it's really obvious. It's 5 pi over 6. And then what's this one here? 6 pi over 6. But 6 pi over 6 is really just pi. That's pretty easy. But then that helps you to see that this is 7 pi over 6. And just keep going like that all the way around the circle. And now, how are we going to get these little spots right here? Well, for example, I'm going to draw in this one in red. That's a 45-degree angle. And so I'd put in the sides 1, 1, and the square root of 2 first. And then I go, oh wait, this is all about the unit circle. I guess I better divide by root 2 on all 3 spots. And then since Mr. Server has kind of reminded me about it, I better really say root 2 over 2. Do I have to? No. You could have said 1 over root 2, and I would have been okay with that. And then remember, now that we have it in this form, it'd be just dumb to go any other way than if I asked you for the sine, it's right there. If I asked you for the cosine, it's right there. I mean, sure, I could do adjacent over hypotenuse, but it's the same thing. So, and now you can start copying things over. So that one goes with, I'm going to make it red over here. That one goes with this one. So those two sides, no reason to replicate the triangle. It's just root 2 over 2. But one of them has to be negative. Which one's negative? Yeah, it's the over part. It's because it'd be going over this way, right? And that's a negative direction, so that one's negative. And then down here, there's another one that's like that. The other 45 degree that's down there, that's also going to be root 2 over 2. But both of them are negative because you went to the left and then you went down. That's going to be the most common mistake, is forgetting negatives. Most common mistake in circle trick. All right, take a minute and fill in the whole unit circle. I'm going to pause for a minute. Let me try that. Oh, and what are these spots here? That's, since it's on the unit circle, that's 0, 1. These quadrantals are just super simple points. You don't have to make triangles for them or anything. All right, I'm going to pause while you try to fill in the rest of the unit circle. Okay, so I need another one that I can bounce around my circle here. Mr. Lucas, can you tell me what we put here and here?
I didn't do that one.
Didn't do that one yet? All right, well, we did do it together then. And this is the triangle I need. This one, and this one. And that's a 30-degree angle. I'll help you with that. And so then it's a 30, 60, 90. So I would have put in 1, 2, and the square root of 3, but then you got to adjust that. What do?
You have to convert it to 1, right?
Yep, so this needs to be divided by 2. So now what are those sides that go here and here? Hint?
X is square root of 3 over 2.
Yes.
And 1/2 for the other one.
And 1/2 for the other one. Good. And then those will bounce over here. So same exact numbers. Square root of 3 over 2 and 1/2. But one of them's negative. Have you figured out which one?
It's the square root of 3 over 2.
Yep. And then down here, can you tell me what should go where?
Where's the, it has to go to the spot.
It's this one.
Yeah.
And then what are the numbers?
Negative square root of 3 over 2 and negative 1/2.
Good. And then I can bop it over here, which is
And then it's just negative 1/2. And then square root of 3 over 2 for x.
square root of 3 over 2 and negative 1/2. And did anybody notice that these other ones that are over here, these are also 30, 60, 90s? It's just that the 30 and the 60 are reversed. Wouldn't it be true then that these two would just be reversed? And then the 1/2 is here? And the root 3 over 2 is here? Is that right? Okay. So if that's true, then this one, this one kind of just tells me this one, because they're both 30, 60, 90 triangles with just the 30 and the 60 moved. So then this must be 1/2, and this must be root 3 over 2. 1/2, 3 over 2, except this one's negative. All right, I think you can see how this could be tedious, but not incredibly hard. All right, let's use one of these things, like over here, to say what is sine of 5 pi over 6? I like to think of that as 5 pi over 6 goes to here. That makes me this triangle right here. Sine is the y. Did you have 1/2 in your head? Raise your hand if you were doing to say a half. Okay, good. Any questions about how you do that? Yes?
I thought you said sine.
Sine is the y.
Oh.
So, pretty sure I got that.
I thought so.
It's all right. Ah, easy mistake to make then. Okay. One last thing I want to add at this point. Put a big A here, a big S here, a big T here, and a big C here. ASTC. That little reminder is super helpful. So helpful, it's just 4 letters. It reminds you that all of them are positive here. Not, this S does not stand for some of them are positive. It stands for the sign is positive. Look, all 3 signs are positive. Sign is the Y, right? Down here, what do you think T stands for?
Tangent?
The tangent is positive. Can you take a negative, divide it by a negative, and you're going to get a positive? See, tangent is positive down there. And every other thing, sine and cosine, which are the other things, sine and cosine are positive, or sorry, negative. But tangent is positive. And last but not least is cosine is positive here. Cosine is the x values. ASTC. So if I tell you that, and I go ASTC, you're supposed to be able to go, if sine is negative, well, I got to go, well, sine is positive here, and it's positive here. If sine is negative, I must be in one of these 2 quadrants, if sine is negative. Do you get to what just happened there? If I said sine is negative, it would have to be here or here. Okay, let's go to the next page. Let's talk about those 225. Like, where in the world is 225? So everybody figure out where you think it is. Well, I'd first be thinking, here's 180, so it's bigger than that. So where is 225? And then draw yourself wherever you think it is. Let's say you think it's there. I'm not saying that's right, but let's say you think it is. Then draw me the triangle around it and put in all the sides and all the angles. To start with, just find me 225. And then I start thinking about the radians for that. Because on the test, listen to this carefully, there is many problems where if you leave the answer in degrees, it will be marked wrong. It'll say you have to give radians. Okay, so I don't especially remember what 225 is in radians, like right off the top of your head. But once you figure out where it is here, then I expect you to be able to go, oh, so that must be, 5 pi over 6 or something like that. Okay, so be able to convert that into radians. I know you can multiply it by 180 over pi or pi over 180. That works, but that's the really slow way. Kind of clunky. All right, so figure out where 225 is, figure out what it is in radians, and draw me a triangle, and label it with all of its sides and all of its angles. And I'm going to say, in this case, I didn't say anywhere that you had to make it a unit circle. So if you want to make it a unit circle, cool. But do you have to? No, you do not. Unless it tells you it has to be a unit circle, you don't have to make the radius be 1. So it's faster to not make the radius 1. And besides, if you notice the title of today, what if the radius isn't 1? So we don't want to be tied to the radius is always 1, because it's not. All right, this is one where, again, I just have a simple triangle. It's drawn in the right spot, and you've labeled it with all the sides and all the angles. Like make sure that if this is a 30, 60, 90, or whatever it is, that you label that and that. That's always a 90. And that. Get all the sides and all the angles, and then the rest of it's easy. Okay? Oh, one more thing. Don't forget this in radians. All right, compare with the kid next to you. So, hoping that your 180 and your 225 made you realize there was a difference of 45 degrees there. So, like 45 more degrees. And so that's 45, and this is a 45, and then this is a 1 and a 1 and a square root of 2. Now, some of you might have decided to make it a unit circle and divided everything by root 2, but you didn't need to. All right, and then this is a bunch of 45s. So I like to think of those as pi over 4s, and if it starts there, 1 pi over 4, 2, 3, 4 pi over 4, so 5 pi over 4. Raise your hand if you had that one right. Okay, good. Now, what's the sine, cosine, and tangent? Everybody take a second and figure out the sine. Notice I don't need to make this point. I can just take opposite and hypotenuse, and I'm done. And I'm okay with that. You don't have to rationalize it. And then find cosine of pi over 4. And find tangent of pi over 4. Caleb, what is sine of pi over 4?
Sine of pi over 4 is.
I'm going to give you a little warning first. I made the most common mistake in circle trig. It's not really a mistake, I just haven't done it yet. So, you know what that is?
Negative root 2.
These are negatives, yes. Okay, so sine is opposite over hypotenuse. So from this one's perspective, negative 1 over root 2. And what did you say? I'm not saying you were wrong.
Negative root 2 over 2.
Negative root 2 over 2 is the same thing, yes. All right, Callie, can you give me the cosine?
The same.
Same exact thing. And then the tangent, Ashana. Toa, opposite over adjacent, and it is positive 1. You got it. Now, was it a surprise that only tangent came out positive? No, I told you that new saying, A, S, T, C. All students take calc. After this class, it's pretty much true. Okay, there's always a kid who's taking stats, but anyway, pretty much everybody takes calc. All right, so, and you might be taking IB version of calc, but it'd still be calc. So this T is telling me that tangent would be positive, and look, it is. All right. Okay, over on this one, this should go much faster this time. Please draw the triangle, and let's just have you figure out cosine for me of this one. Cosine of negative 7 pi over 6. You should know which direction to go to make a negative angle. Draw the triangle. And I'm going to say this so many times you're going to be sick of it, but as soon as you have the triangle with all of its sides and all of its angles, the rest is easy. It really is. It's the hard part is making it have all the right sides and all the right angles. From there, everybody can do cosine. It's just SOHCAHTOA. Just make sure you're going to the right spot. This is where I started going my pi over 6s. That's negative 1 pi over 6. And then I'd probably jump to this one and go, that's negative 6 pi over 6. And so then that's where negative 7 pi over 6 is, that blue line. Raise your hand if you were doing it in the right spot. Okay, good. All right, Mira, take it from there. Okay, what are all the sides and all the angles?
So the angle faces 30 degrees.
Okay, this one's 30. So then this has got to be 60. Then what?
And then a 35 degree
So what sides?
So your radius or your hypotenuse will be 1.
All right. I'm going to do it this way. 1, 2 square root of 3. And then if I want to, I can make this be a 1 by going like this. You weren't wrong. I just am doing it a different way. Okay, now what?
And since your cosine is your x value, cosine will be
What's the most common mistake in circle trig? For and negative. Okay, and now what? So final answer, cosine is adjacent over hypotenuse, which is that divided by that. Now, would I have even needed to divide everything by 2? No. If you can still see it there, it would have been square root of 3 over 2 either way. But there is a negative. And there we go. Okay. Any questions? A, S, T, C. Only sign should be positive in that quadrant. We were doing cosine, so it's good that it was negative. Because it's a way to double check yourself too. All right. So then, tell me this. What if the question was just, what is coterminal with negative 7 pi over 6? What that means is, what terminates in the same exact place, but isn't negative 7 pi over 6? And the answer is, if you came from this way, it would terminate in the same exact spot. That's what, well, they're called coterminal. They stop in the same spot. So then that would have been 5 pi over 6. Do you get that that's 5 pi over 6 just as much as it's negative 7 pi over 6? They stop in the same spot. One's positive, one's negative. It's one more way to get coterminals, and that's to add and go all the way around the circle again. So 5 pi over 6 plus 12 pi over 6, because you're going to go around a whole nother time. You just don't stop going around. You just go around and stop after another 12 pi over 6, which makes 17 pi over 6. I added a whole nother time around the circle. Okay, so that's another coterminal angle. Okay, enough about coterminals. Man, so many things to know. None of these are incredibly hard, but there are a lot of them. Now, what was the title of this lesson again? What if the radius isn't 1? So, let's get to that. We've done enough. You know what? It wouldn't hurt to just do one more where I don't give you any advice. Just try sine of negative 11 pi over 6. If you can find it and draw it, and once you get your triangle and all of its angles and all of its sides, this should be easy peasy. Giving you 30 seconds. Find the sine of negative 11 pi over 6. Notice it's negative. Huxton, is this the spot?
Yes.
Good. And as I draw my triangle there, what are the sides that you'd put in if it was you?
Put 1 on the right, and then 2 on the line.
Yep.
And square 3.
Good. Nothing anywhere said it had to be the unit circle. So we can just do that, and then sine is opposite of hypotenuse. What's the answer?
Square 3 over 2.
Opposite over hypotenuse. From this angle's perspective, which one's the opposite?
1 over the square.
1 over the hypotenuse?
2.
2. 1/2. The end. Raise your hand if you had 1/2. Okay, good. And then my answer came out positive. Does that make sense? Yeah, all of them are positive here. S, T, C. Okay. Now, I'm ready to move on to the next page. So here is where all of a sudden, if you were so reliant on the unit circle that you only could do it when the radius was 1, you'd be toast, because now the sides are all weird. But if you've been drawing the triangles, like I've been trying to show you, then this will be really not a big deal. All right. Sine of theta equals negative 7 over 25. Okay, well, I'm not sure exactly what that means, except sine is opposite of hypotenuse. Didn't they just give you two sides? Sine is opposite of hypotenuse. Think about that. Didn't they just give you side 7 and the side of 25? They did. Okay. With theta in quadrant 4, automatically I'm just going quadrant 4. I know where that one is. Do you guys know that quadrant 4 is right there? So I'm going to get rid of all the rest of them. I'm just going to cross them out. I know they've zeroed me in on this quadrant. That's where it is. And now if I'm going to draw a triangle for this, my advice to you whenever you draw this triangle is always make it look kind of like it has a 45-degree angle. A really common mistake is kids will draw their triangle like long and skinny like this. And that's a really bad idea because you don't know how big that angle is. What if that angle is actually 60 degrees? Then do you get how everything's messed up? So my advice is draw short, fat triangles. Because I could believe that that angle is 30 or 60 or 45, and it doesn't bother my eyes if it's actually like the other one where the really small angle is all of a sudden supposed to be 60, really messes with your head. But if I say this is 60, it doesn't bother me that much because, so it's off a little bit, but it's not off much. So when you're drawing a triangle like this and you don't know what the angles are, make it short and fat. Okay, so everybody got a triangle drawn in there? Okay, now, remember it said sine, which tells me this is the opposite. Right up here, that's the opposite, and that's the hypotenuse. We are definitely not in the unit circle, because the hypotenuse in the unit circle would have been 1. So sine is opposite. From this angle's perspective, that's the important one. There's 2 names for that angle. Man, so many things to know. Henry, can you give me either the names for this angle? Okay. Caleb, can you give me either the names for this angle? Yeah, that is theta. You got me there, but there's names for it, like it's the blah angle. There's 2 names, and you're all supposed to know them. Okay, now I'll take volunteers. See, you didn't write it down apparently before, or maybe some of you did. Sam? Okay, you're giving me all, those are all good things, but they're not the names for that spot. What you just gave me is something called coterminal, and that's not what I'm looking for. This is called the blah angle, yes? Central angle, yes, that is called the central angle, and it's also got another name that would have been just as good, yes? What? It is an acute angle, can't argue with that, but there's 2 names for the angle that's in the middle. It's called central angle, and it's called the reference angle. Reference angle. It's going to come up on your test. That's why I'm pounding it in here. That's the reference angle, and it's also called the central angle. All right. So that's the angle. That's where theta lives, right there. Because there is 3 angles in the triangle. We never use the right angle, of course, and we only use the central angle. All right, so that central angle's perspective, from that angle's perspective, the opposite is 7, and the hypotenuse is 25, and I'm missing something really important. What?
The 7 is negative.
What?
The 7 is negative.
The 7 is negative. Very good. That is a negative 7. Could the 25 have been negative? No. Can't have a negative radius, also known as the hypotenuse. Can't have a negative hypotenuse. Okay. Cool. Now, do you remember me saying that as long as you draw in the triangle and all of its angles and all of its sides, that you'll be able to answer anything? In this case, do you get that there isn't like a really, this isn't angles that you know. It's not a 30, 60, 90. It's not a 45, 45, 90. I did tell you early on a Pythagorean triple that would be handy right now. I think only Sam knows these. Anybody else? Yes? It is 24. Very good. 7, 24, 25. Now, how could you have gotten that if you didn't have that memorized? 7, 24, 25. She had a big advantage over everybody else. How could you have gotten it, though? Oh, you could have. Yes?
You could have done 25 squared minus negative.
Yes, you remembered this other thing I taught you, which is the third side of the triangle. You can just take 25 squared, which is 625, and 7 squared, which is 49. And is this the longest side? No, so then I'd subtract. And then you'd have to do the square root of all that, and it'd be a pain in the butt, but you know what it comes out to? 24. Because it's the 7, 24, 25 triangle. It's one of the very few that you should memorize. I'll remind you, 7, 24, 25. 3, 4, 5 triangle is one of them, of course. And 5, 12, 13. Memorize those. You know why? Because we're doing right triangles all the time. Of course, we're going to every now and then use one of these Pythagorean triples. Okay, so here we are. We're about to figure out the answer to the question. What is the answer to the question? Well, what is the question? Anya, can you dig back into the question and what do they want to know? Because I've got all my sides now.
They want to know what the cosine of the central angle.
Notice you didn't need the angle. You needed the cosine of the angle. And again, if you were obsessed with the unit circle, this would be very disappointing because you're not going to be using the x or the y value. You know, sine is the y, cosine is the x. But If you're used to just doing normal sine, cosine, tangent, cosine is adjacent over hypotenuse. That over that. So it's 24 over 25. It always boggles my mind how many things you have to know to do circle trig. You had to know which quadrant 4 was, or you were stuck. You had to know how to draw the triangle correctly. You had to know which of the three angles in the triangle you are supposed to use to figure out like opposite and hypotenuse. You had to know that sine is opposite over hypotenuse. You had to know where the negative goes. You know, like one of these was negative. Oh my gosh, there's just so many little things. This is why trig is considered harder than first semester. But I'll keep reminding you of all these little things, and you'll probably do fine. Kids with A's usually keep getting A's. But frankly, usually what happens is kids with B minuses start to get C's and D's because it just starts overwhelming them. So fight that. If you're one of the kids that's been just kind of holding on with B's in this class, this is the part where you have to kick in more time. All right. You shouldn't need me. You should be able to draw this triangle in the right spot, label all the sides, and in the end, once you got a triangle with all of its sides and all of its, well, you don't even need all the angles in this kind of problem. If you just have all the sides, you'll be able to answer that question really easy. I'm going to pause for a second, give that a try. So I'm thinking that this says quadrant 1, and therefore I'm crossing off this, this, and this. And I'm going to draw a short, fat, I'm telling you, this matters. Some of you are going to draw a skinny triangle. Not a great idea. Because it'll deceive you then later. Cosine is adjacent over hypotenuse. A 4 and a 9. What's the third side? That's not one of the ones you told us to memorize, Mr. Server. So then you got to break out this. Who had a square root of 81 minus 16? Raise your hand if you did that. Cool. What is 81 minus 16? 65. So then let's use square root of 65. Do you have to simplify it? You should if you can think of some way to do it. Was there a way to do it? Okay, then let's leave it as square root of 65. Then I said once you got your triangle labeled with all of its sides and all of its angles, but we don't really need the angles because we need sine of the angle. And that's opposite of hypotenuse, which is root 65 over 9. And that's it. Raise your hand if you had that one right. Cool. All right, I feel like I have done my job. You've seemed to follow me the whole way. Do you recognize this page as one we already did as an assignment? Okay, if you never did it, you should really do it because this was critical, super important stuff. But now this is really important right here. Honestly, this is the main question of circle trig, which is this whole chapter, is this question. So let's do one together. I'm gonna assign all of them on this page. These are so super critical. Okay? So you should do this page mostly today. All right, so let's start it. Number 31, sine of theta equals a half. And it says find all of the angles which satisfy that. Well, first thing I've told you to do is draw yourself a little picture, and I recommend you start doing ASTC every time. It doesn't take much longer, and it really helps. And now sine is a half. Notice it doesn't say it, but that is positive. Do you agree that sine here is equal to a positive number? Do you get that means we can cross off this and this? They're out because sine is positive. So then you draw yourself the triangle and you label the sides. Sine is opposite and hypotenuse. Ooh, I know this one. I can do this one in my head. 1, 2, and what's the third one? Root 3. And then do you know what angle this is? Hint, it's the reference angle, and it's also called the central angle. Good. So that angle, what angle is it? 30. Yay, I'm done, except you just all got it wrong. Come on, come on. Come on. Pi over 6. There it is, because notice, look at this. In radians, which is between 0 and 2 pi. Okay, so 30 is really easy to think, and it's not wrong until you write it on a paper. Final answer, theta isn't really 30, it's pi over 6. And then it's also wrong. What? Because there's another answer. Once I've got this one, though, this is kind of cool. I can draw this second triangle and say, there's got to be one here, too. Look, sine was positive in both of those two spots. And then I can just copy the numbers over and go, well, it's got to be 1, 2, and square root of 3 again, except this time this is negative. And then I go, the answer isn't 30 again, though. In pi over 6 world, what is that angle right there? How many pi over 6s? 5 pi over 6, so that's the answer. Theta is also 5 pi over 6. Do you get there's two answers? Because it's happening in two different quadrants. This was 1 pi over 6, and it worked. It was one of the two triangles. This was 5 pi over 6. That's the other reference triangle. All right, let's do another one. I'll do number 32 with you. What am I missing off my drawing that I should have every time, Ashna? 4 little letters.
A, S, X.
Yep. Then, cosine is negative, Sam. What does it rule out? A is out, and cosine is negative.
Oh, no, A is.
A and C are out. If cosine is negative. Okay. Now I'm going to draw just one of my triangles. Mr. S, Mr. Soap, can you tell me which of my sides is square root of 3? Yep. And then this is a 2, and then which one's negative? Yep. And I know this one. 1, 2 square root of 3. And this is, I totally get this mistake. The kid's going to go, across from the one is a 30, also known as pi over 6. So the answer is pi over 6? No. Pi over 6 lives here. The answer isn't pi over 6. It's all the way to here. So what is it? 5 pi over 6. And then there must be another answer. And hint, you don't even have to put in the sides because it's an angle answer. And it was 5 pi over 6. This would make it 6 pi over 6. That would make it 7 pi over 6. See how I don't even have to draw out my whole triangle there? I can just figure out that the angle must be, move a couple more pi over 6s. So 5 pi over 6 and 7 pi over 6. These are so critical. Do this whole page. Then on the next page, strongly recommend 40 and 42. And I know some people are going to freak out with this one. Don't freak out. Think it through. Draw it out. Try to figure out what's going on. And then you can look at the key. Okay. And if I could only pick one problem that represented today super well, it would be this one. I'm only going to give you one like this, that one. Strongly recommend that. I can't tell you how close this assignment is to your test. It's got several of your test type questions in it. Choose to not do it at your own peril. You're not practicing exact kind of things you have to know for your test. So when's your test? Well, today's or tomorrow's going to get blown up because of the ACT stuff, right? And then tomorrow we're having a quiz. No, sorry, not tomorrow. The next day, Wednesday, we're having a quiz. It's an in-class quiz. Okay, so it's only in the formative, but it'll give you a good chance to see, am I understanding it up to here? Then we add some more stuff on Thursday, and then we review Friday, and we have a rare, not amazing, but Monday test. I think it's Monday. It's either Monday or Tuesday of the following week. So bottom line, it's not this week. And tomorrow is not tomorrow. Tomorrow is a weird day. The next day, the next class day we have is a formative quiz. I don't wanna make it sound too scary. All right, that's all I got for you for today. After this, you don't have to do any of the homework problems that come after this.